Hello everyone, it's Mr. Christie back at it again. This time I have a question from one of my students, Inaya. The question involves trig equations, or trig graphs rather, and graph transformations. There are two graph transformations occurring here, one represented by A and one represented by B. The first one looks like to be a stretch, or is a stretch by scale factor 1 over A. And the other one is a translation, but it's not exactly, some of you might look at that and think it's a translation by the vector b0. It's not exactly that, and we're going to come back to that. The first one I'm going to work out is the value of a, and as we said, a represents a stretch horizontally by scale factor 1 over a. And so what I'm going to do is I'm going to use the period of the typical or the standard sine graph to work this out. So if I look at a standard sine graph, it goes to the 0 and 360, and what we can see here is the period, or we can think of it as like the width of one oscillation is 360 degrees. So if I can work out the width of one oscillation of this transformed one, I can then work out what A is, right? So for example, if A is 4, then I would times 360 by a quarter, and the period would be 90. So if this was 90, I'll do 360 divided by 90 to work out A. It isn't that here, but we'll work it out precisely right now. So what I'm going to do is I'm going to do 198 take away 18, which tells me that the period of this transformed graph is 180. Basically, it's been halved, which tells me that A is 2, because remember, it represents a stretch by scale factor 1 over A, the reciprocal of that number. Now, to do that more mathematically, I don't need to, but I can just do 360 divided by 180 to get that number, which is 2. Now, here's where the common misconceptions occur. So let's be very careful here. Let's tread very carefully here. Now, the graph goes through 18, 0, and the typical sine graph, y equals sine x, let me just make this clear, y equals sine x, goes through 0, 0. So one might infer that, oh, wait a minute, it's moved 18 to the right, and therefore b is 18, and this is incorrect. And this is to do with the misunderstanding about the order of transformations. Because it's typical to follow BIDMAS in certain situations, a student might think A comes first and B comes second, when in fact B comes first and then A becomes second. Now let me make this a bit clearer by writing this out with A being 2, so y equals sine 2x minus b, and then I'm going to take out the 2, right? So 2 brackets x minus b over 2. And what we see here is the translation is not by the vector b0, but b over 2, 0, and then the stretch by scale factor a half occurs. So that means b over 2 must be equal to 18, right? Because it's moved b over 2 to the right. No, let me make that, yeah. And therefore b is 36. Okay, I think I said something slightly incorrect here. So the stretch occurs after the translation, and I did this to work out what b is. So to make this clear, if it isn't clear, the translation is by the vector 36, 0, so it would look like this. Right, this is before the stretch occurs, so it goes through 36, it would go through 180 plus, this is normally 180, it will go through 216, so this is not, well, it's not the greatest thing. Let me just do like this. And then what happens is the stretch by scale factor half occurs, and now instead of going through 36, 0, it goes through 18, 0, and there's my answer. Just one more thing. So I think I kind of breezed over this. So it is a translation by the vector 36, 0 first, followed by a stretch by scale factor half second. So when I said it's not exactly a translation by the vector b0, I meant doing that after the stretch. But if you're doing that first, then you're doing the stretch by scale factor half. So that is the correct equation of the graph.